Good evening, everyone. Thanks for investing your time in attending this webinar. Good morning and good afternoon to the audience from the other geographies. Today we are going to talk about the topic IoT, what it means for equipment manufacturers. I am the presenter. My name is Viresh Dharappanavar, and I work as a Senior Director of Sales at Altizon Systems. So just talking about me a bit, I have about 18 years of work experience, and this comes in from various sectors, starting with process industry, where I could work with a lot of process instrumentations, SCADA, PLCs, etc., and industrial market research, and IT for the past 8 to 9 years. But throughout my career, I have been a sales guy. This is where my profile brings in. Let me move ahead. Just know how we can interact with each other. So the audience will be on listen only mode. So the attendees can interact with me in two aspects. They can post their questions over there in the chat tab, as well as they can also raise their hand if they have any questions to me. And also, please make sure that you have kept your mic and speaker on over here. Use the menu that is on the right hand end of your screen. So let me move ahead. To begin with, I'll just take one slide to talk about who we are, where we come from, in the form of a scorecard. So our core competency is the platform, a big data Internet of Things platform called Datonis. This is a unique platform which has the capability to understand the data coming in from the machines and process huge amount of data that can be utilized to create a lot of interesting applications on top of it, so that one can always use this information for business benefit. Talking about our scorecard, we were established about 2 years ago, and in these 2 years we have earned about 50 plus customers who are using Datonis platform, and in which 12 of them happen to be paid customers for us. And these 12 customers are a mixed bag of customers, in various industry sectors. We have worked with automotive manufacturers, automotive ancillary companies. We are working with a large Japan-based consumer durable manufacturer. We have worked with smart city projects. We have worked with smart grid projects, etc. So this mixed bag of experience has really enriched the platform that we have. And last but not the least, we have about 10 plus global system integration partners. And these partners are primarily industrial automation companies, as well as hardware manufacturing companies. These are the companies which help us make the machines IoT ready, as well as churn out a lot of hardware which are required to make machines IoT ready. There are two elements that we try to address in our entire offering. One is the remote condition monitoring, very relevant to the topic that we are going to discuss today. And second is the overall optimizing the OE, the overall equipment effectiveness, very relevant to manufacturing setup. They would like to know the efficiency, productivity of the machines, and then how they can optimize their OE. The next slide, I will move to content. So what is it that you are going to get in the webinar today? So we'll start with talking about what is big data and what we are talking about, and what it means as Internet of Things. So making it more relevant by talking about what is the equipment manufacturing scenario that the OEMs or equipment manufacturers go through right now, including their scenario as well as their challenges. We'll talk about a case study that we have with a global pump manufacturer, and we will try to address the benefits and the ROI related queries in the slide. Also, last but not the least, we'll talk about how we can get the equipment manufacturers ready for IoT. Based on the understanding and learning that we have, just created this particular chart. So what it means is about 90% of the data was generated in the last couple of years. So what it means is, we have been churning a lot of data, which is coming from various avenues, be it social media websites like Facebook and Twitter, trading portals, news website, weather portals, and our smartphones where we are generating a lot of data, and of course machines. Machines have been generating this data for last couple of decades, but more or less this data has been used for monitoring as well as controlling of the machines on the field. So this is where the big data comes into picture, generation or the creation of such amount of data. What Eric Smith talked about in the last 2-3 years ago, that every 2 days we are creating as much information that was available on the World Wide Web in 2003. That was about 3 to 4 years ago, but today if I could look at, it would be, I don't know whether we might be generating this amount of data in a couple of hours. So this is where the big data aspect comes in. So looking at the way that we are generating the data, it is anticipated that we would grow 50-fold in the next 5 years. So considering this amount of volume, there is a dire need for systems or platforms that would help consume this data and process this data. Now, my next picture talks about making IoT ready and giving an explanation about IoT. But before I jump into explaining this diagram, I would like to quote these words from Michael Porter, which I read from one of the HBR articles called Internet of Things: How it can create competition, how you can eliminate competition through this particular technology. Porter explains there are three waves of information technology. The wave number one, which came to us a couple of decades ago, and this wave was creating more or less IT in the value chain by just optimizing our manual processes. So it was replica for the manual processes, and then, or rather, digitizing the manual processes. The wave number two created a lot of applications, and these applications started interacting with each other, optimized the processes, and also these applications went beyond the boundaries of the manufacturing unit, for example, to different geographies, different locations, inter-departments, etc., and also exceeded the boundaries of the organization and connected with suppliers, with customers, and created this particular value chain. And the wave number three that Porter explains, which has emerged about 3 to 4 years ago, and this wave, it has nothing to do with the value chain of the enterprise. It has got to do with making the machines IoT ready, or making machines smart. That means you are embedding the internet into the machines. So what it means is, if you could see the bottom of the pyramid that we have, are physical equipment. So these can be gearboxes, turbines, or decanters, cooling towers, etc. So these are physical equipment, and these are already having control systems, be it in the form of PLCs, SCADA, etc. So these control systems have, they are good at controlling and operationalizing the whole equipment. But what I can say, the challenge that these control systems have is storing the amount of data that the systems generate. I'll give an example. So you're looking at the turbine over here, a 10 megawatt gas turbine with about 230 odd sensors is able to generate about 200 gigabytes of data per day. So in this, if you consider these kind of situations, you need to have robust systems which can consume that amount of data. That's when you need data collection and processing kind of a systems, which we bring as on the table as Dataonis. So in order to bridge the gap between the data collection and processing platform, through the control systems, we need to have communication network. So these communication network can be in different forms. Namely, we can create a hardware which will aggregate the data from the equipment and then push this data to the cloud platform, or we directly consume the data from the control systems, which are PLCs, DCS, and SCADA, and collect and aggregate and then push it to the cloud system. Once you do that, you need to do something creative with that particular data. Just having a data, it doesn't mean anything. So one can always create a lot of meaningful applications with the data that we have. So there can be a lot of predictive analysis that can be built. We can get a lot of information with respect to usage and performance of the equipment. I'm moving to the next slide called equipment manufacturing scenario. To begin with, I read a interesting note from US Federal Reserve, which says that about 10% of countries' manufacturing related economy is generated by equipment manufacturing industry. So that's good news. We are making a lot of impact on the country's related revenue. Let's talk about the scenario that the equipment manufacturers bring to the table. There are 6 scenarios we observed. So breaking it down, so let's talk about high mix and low volume. Let me give an example. If I could look at a gearbox manufacturer, for example, and I would look at the kind of offerings that they bring to the table in terms of product ranges. So the gearbox manufacturers can bring to bevel gears and helical gearboxes, the spur gearboxes, rack and pinion and worm, and so on and so forth. But if you could look at the high amount of mix in terms of offering, but they would be definitely having low volume. So this is one of the scenario that the equipment manufacturer have. And second is the high lead time. So the lead time for manufacturing is not in days or in hours. It is definitely weeks or months. So this is the range of lead time that we are talking about from the date of the order receipt to the date of the delivery. Third is the product mix. So the product mix is the combination of make to stock products, for example, a combination of engineer to order, configured to order, made to order. So if you have these kind of product mixes put together, because every customer that come to your table have some kind of a tweaked requirement. We end up manufacturing such equipment for them, and it is very hard to manage such kind of a vast product mix. The other aspect comes into picture is the complex order entry. So this order entry we are talking about considering the direct involvement of the customers in the manufacturing process when they give an order. So they are involved in the design, they are involved in the manufacturing process, they are involved in the supply chain. So that is the need of the day to day. Most of this process, when you look at in terms of visibility, comes to manual. Salesperson talks to the production manager and collects the information and then passes on to the customer. Having any lapses in this particular process creates a lot of negative impact, which the equipment manufacturers have lived on this particular challenge. Then project-driven processes, since the orders that are received are more or less custom and there are some tweaks to be made in the product. So eventually they end up into manufacturing into a product or a project-based driven process. So traditionally, it is a common phenomenon for the manufacturers to get involved in project-based manufacturing process, but they are used to that. But in many cases, because of the competitive pressure that they come in and the reduced lead time, they usually end up into such processes. But having agreed to such process, it becomes very difficult for the manufacturers to manage the entire production, control design, cost, etc. And in many cases that we have observed, and sometimes it has been a common practice as well, they usually start production or the procurement process for the parts, etc., even before the design is completed. And the challenge over here would be that once the customer tweaks the design, and then the whole value proposition and the cost structure goes down. And last but not the least is the after sales support. In the past, this after sales support component was embedded into the product profitability margin. And today, most of the organizations create this as a different entity and put it as a profit center. Now, let's talk about the challenges that the manufacturers face. Number one is cost reduction because of the competitive pressures that the companies have. So this is not a new phenomenon. Most of the equipment manufacturers go through this particular process of cost reduction. Ease of doing business. Let me explain how this impacts. So considering today's digital age, a lot of processes and IT systems are in place, but the whole business still is conducted by people. So given the vast amount of options available for the customer, many times it is difficult for the customer to make a decision on whom to deal with. So in most of the cases, purposefully or cautiously, the firms are evaluated based on how easy it is to do business with them. So that also creates one of the key factors for the decision making. Third is the planning and managing the growth. So the CEOs ask questions day in and day out. These are the questions that they don't allow them to sleep. So these questions revolve around should I have a planned or an optimistic approach? For example, should my growth be driven by new products or by innovation? Should I go into new sectors or should I go into new markets altogether? Or should I build new synergies by acquiring some other company? So these are the questions that the manufacturing organizations face. And interoperability. So just simply explaining it, it is the ability to seamlessly share either technical or business information throughout the extended manufacturing process. As simple as that. It can be inter-department, inter-manufacturing, between geographies. One hand talks to other is where we are coming from. I could learn about this aspect in one of the report published by NIST, the National Institute of Standards and Technology. This report said that the automotive sector lost close to $5 billion inefficiencies in the supply chain process only. So that's a huge amount of loss that we are talking about. Lastly, it's a globalization because of the mature marketplace, which some countries really enjoy. The options available to the company becomes limited. So here, even if the company is coming up with some innovation in their product, they are able to make some profit margins in a limited period of time, but they are able to lose that particular edge because the competition will catch up with them sooner or later. So in the next slide, I will be talking about a case study that we have done with the global pump manufacturer. So this pump manufacturer wanted to provide a service for condition monitoring and predictive analysis. They came to us, they want to saying that they want to maintain and service pumps which are located in a remote location. So with this particular challenge, the first thing that we did was to analyze their equipment. So talking to them, we learned that these equipment generate. By the way, these were high-end pumps which were critical in terms of process and in terms of value also a bit high. Pumps had about 20 odd parameters to be monitored. So these ranged from the motor as well as the pump as well as the accessory of equipment or the sensors that are placed in various locations besides these systems. So here the parameters were from the motor. For example, it was voltage, current, frequency and power. And also there were motor and pump bearings. Bearings were providing both amount of data that would be vibration as well as the temperature. And there was other gauges which were suction pressure gauges which were doing a lot of suction and pressure discharge pressure measurement. And also they had a flow meter which gave them liters per hour kind of an output. So the Pump also provided them with running hour meter. So if you could look at this particular system and the parameters that were generated, this system was generating the parameters in various aspects. What I'm talking about is from the motor, we were getting from the data in the form of a Modbus RTU slave, and we were getting from bearing on two aspects, from 2-wire RTD sensors to 4 to 20 milliamperes. So again, a varied kind of an output that is coming in. And from the flow meters, we are also getting the 4 to 20 milliamperes, and the pump running hour meter was giving us in 24 volt DC. So considering these varied inputs, we had to create an hardware which you see in the form of an Elliott box over here, which consume the data from these varied sources, be it RTD 4 to 20 milliamperes, 0 to 24 volt DC, and collected and aggregated this data and pushed this data to Datone's platform. And once it was pushed, then we could create a lot of analytics on top of the system. So the analytics I'm talking about, having, for example, a predictive analytics, which was more or less relating to the asset condition or wear of the asset. So it would be mapped with, say, vibration, increase in the vibration, monitoring the increase in the vibration, map it with the amperes that the motor is drawing, and the temperature that the bearing is providing. So based on these three, map a particular threshold, and based on that particular threshold, you would ideally come to know that which is the component that might fail in the coming days or coming weeks, and communicate with the customer appropriately. So this was the overall system that we built for the global pump manufacturer. I'll just rush through because I see that there is a challenge in time. Talking about the benefits and how one can define the ROI. So ROI thought about making it into 3 bits and then again divide it into 2 aspects. First of all, offering exceptional service. Having visibility on the product performance, one can always proactively support their customers. And with this particular visibility, you can decrease the number of field visits that one can make, and this eventually reduces the high cost of service. Imagine, a manufacturing plant which is using your equipment, and then you have been called number of times to serve this particular system in a warranty period. Look at the cost that you will be investing. Now, talking about revenue, so when you have this amount of visibility, you definitely reduce the mean time between failures, MTBT, and the downtime. And you can also engage with your customers in an innovative way. Looking at the way that they are using the equipment, you can always tweak the SLA and then get more revenue out of it. Now, visibility, having optimum visibility, if a service engineer is going to fix a certain issue, you know that what is the kind of issue and the reasons for these issues, and then the service engineer might also carry the appropriate parts to fix these issues. And of course, predictive maintenance, which we talked about how our pump manufacturer is doing, calibrating 2-3 odd parameters and putting a threshold, and then based on that threshold you are able to generate a lot of analysis in terms of failure, and utilize this data in terms of product improvement as well. Having the data of usage and performance, it will definitely help in improving the product. And in terms of revenue, you can reduce the false warranty claims which are provided. Most of the cases, customers do tend to say that this is your equipment and it's under warranty and you need to take care of it. You can always tell them that, look, sir, this is the real-time aspect that you have, and then the warranty is applicable or not applicable. And similarly, you can also plan for spares, based on the usage that data that you have in the real time. You can always plan in advance for spares. The third ROI definition would be differentiation. Introducing a lot of new engagement models with your customers, in terms of payment terms, use by usage wise payment terms, etc. So one can always bring together new engagement models and enrich customer engagement. I'll just quote an example over here. I was talking to one of the Europe-based manufacturing company, and then they already have implemented such systems on their equipment. So they said that this data helps them engage with their customers in a proper way. Traditionally, they used to call up and then ask for a meeting and stuff like that. Today they have data to call the customer. They would call the customer and say that, look sir, I'm looking at the shock versus the vibration versus the pressure and versus the temperature, and then based on this you are likely to face these three issues. And look at the customer's pattern now. They are immediately called to talk about it, and when they go there, they not only present this analysis, but they can also benchmark this analysis with the industry. So if they are, for example, if the customer is in say manufacturing of automotive cars, and then they can always benchmark that particular usage pattern with the other car manufacturers. And the next question that the customer would ask, definitely, how can I achieve that particular standard? And once the question has come that you have not hard sold, you have not done any hard selling, you are definitely there in terms of selling new offerings. So that's where the increase in after sales revenue comes into picture. So I had the opportunity to meet a couple of large global equipment manufacturers where both of them agreed that about 25% of the entire revenue of the company is allocated to after sales revenue. This is how one can try and increase their after sales revenue. Now looking at all the aspects and the enrichment that the customer gets in, so you really end up increasing the market share, because you are creating a lot of opportunities within one customer so that they can start giving you repeat business. I'll move to the next slide. Okay, I've already started getting some questions. I will address it after the completion of this slide. The how do we get the manufacturers IoT ready? So we have broken it down into 4 different stages. So it would be a product stage, and then making it a smart connected product. So stage number 1 is always that the manufacturer asks us, can you make my system IoT ready? Can you show this to me on one equipment? So that's how it starts. So that's a stage 1 where we make a pilot and we showcase the capabilities of the systems. And then the stage 2 comes in, where in this particular stage number 1, we have closely interacted with the customer and then churned out the challenges and the expectations that they have. And based on that, we go ahead and create an hardware, for example. So this hardware, creation of hardware takes about 3 to 4 months. It's both creation, design, manufacturing, as well as testing. So if you could take design and manufacturing versus the testing, it would be equally distributed into the time frame of 3 to 4 months. And after that, the customer chooses a sample of their equipment, maybe 50 of them, to churn out into stage number 3, that is field testing or field trials. So in these field trials, this is where the rubber meets the road, and customer would like to test how the equipment are performing, in what conditions, and what are the typical issues that we face. Once we get these field trials and then get our learnings, that's when we tweak the system, and then in the 4th stage we go into mass production. That's where we are talking about smart connected product at the birth. So I just shot over a couple of minutes. I'll take these questions. I have a couple of questions. So the first question that has come to us is, what are your challenges in implementing IoT? Good question. Let me break this particular challenge. Let me break this particular challenge into 4 parts. Number 1 is communication. Where I'm talking about communication is lack of what I can say standards within the network. So if I could take only the example of the PLC. So the PLC are manufactured by different manufacturers, and they have their own proprietary software. And sometimes the PLC manufacturers have a lock-in key so that the data doesn't go out. So there is lack of standards over here because of these proprietary systems. So the communication, getting the data from the systems is one of the challenges that we have. Second challenge is primarily asked by the IT guys or the CIOs, CTOs of the company. How secure will be my data? So what if someone hacks on the system? So we have built our system in such a way that it is able to bring the secure information on the platform, and it also has a key-based authentication process. Then the third would be process of implementation. And as you rightly see that the overall one implementation goes anywhere from 6 to 8 months for an equipment manufacturer. So although if we might have worked with a X product, and if I go to the same manufacturer, and then this still doesn't apply, they will still ask us to go through the process. They would say that although you might have done it for this particular company, but please show it on our product. The fourth is the analytics. So great, we have the data, we have the process data, and then what about the analytics? How do you create those meaningful outcome of this particular data? So we try to address in two aspects. We do have data scientists who use this data and then create meaningful outcome of the data. And second, I think this is the most preferred way where we communicate with our customers, and then request them that since they know their business better, they know their equipment better, they are the best people to educate us in terms of what are the how to use this particular data, and then map the critical parameters, and then if there is a tweak in these parameters, and what would be the impact. So this is where our challenges are, and I try to sum up these challenges. The second question, how do you handle different products? Okay, good question. So handling different products. In my narration, I talked about we have worked with various organizations in different businesses. This says that the Datonis as a platform is able to handle heterogeneous equipment, and then we are able to handle different kind of equipment, and every equipment brings in different kind of real-time sensing data. It has variable latency. It brings in different kind of data in outputs. So talking about the pump, one particular pump brings in about 4 to 5 different kind of outputs. So we are able to handle such complexity within an equipment or in the various kind of equipment. The third question is, will this PPT be shared? Yes, we will share the PPT over email. Thanks everyone for your time. Sorry, I short up by about 5 minutes. Thank you very much for attending the webinar. I hope it was useful. Thank you.